The following is a summary of T-walls, L-walls, and gates as designed in the New Orleans district for the Corps of Engineers. These are typically reinforced concrete water retaining structures that are founded on deep battered piling and are capable of carrying large water loads. Gates can have steel diaphragms as their stem and are placed on reinforced concrete foundations. For each of these structures, a seepage cutoff is typically provided by driven sheet piling that is designed to limit the potential for piping and the potential for heave on the protected side. And geotechnical analyses of these particular structures is focused on unbalanced loads in the soil profile acting on the piling that support these T-walls, L-walls, and gates. This is a side view of a typical T-wall that's taken out of the HSDRRS manual from June 2008. The T-wall is located here and is essentially an inverted T. Driven battered piling is located below the footing and attached to the footing of the T-wall and typically driven into the deeper Pleistocene deposits. And the entire analysis is focused upon the unbalanced load or the magnitude of the load acting on the driven piling underneath the foundation of the T-wall as a result of the water load on the flood side. In the HSDRRS manual, the description of a T-wall is that it's typically 4 foot in height or greater, and L-walls are typically 8 foot height in maximum, but they cannot carry unbalanced load. T-walls are preferred walls where there's the potential for a barge or boat impact loading and where there are unbalanced forces that result from a deep-seated stability analysis. L-walls can be used where there might be barge or boat impact, but they should not be used in a situation where there are unbalanced forces that are present because of a resulting deep-seated soil instability. Gates are similar to T-walls in the sense that they can have unbalanced loads and they could be designed for barge or boat impact, but they have a removable stem wall that permits normal passage during non-flood conditions. For all of these structures, the analytical process is the same,